Very good morning, dear students. So welcome back again to the lecture number 12 of chapter 7. In its previous lecture, we have discussed about two examples from the NCERT books, and in this lecture, we are going to solve one example as well as one problem from the exercise 7.2. So let us start with the first question. The first question is, in an isosceles triangle ABC. It means there is an isosceles triangle ABC. So in an isosceles triangle ABC, in this triangle with AB is equal to AC. Since it is an isosceles triangle, and in this triangle this side is equal to this side. This is clear. D and E are points on BC. So on BC, D and E, D and E are 2 points on BC, such that this distance BE is equal to CD, this distance. Understood? So D and E are 2 points on this base BC, such that the distance from B to E is equal to the distance from D to C. Okay? So let us first write down the given statement. So it is given ABC is an isosceles triangle with AB is equal to AC. This is given. Okay? And it is given that D and E are 2 points on BC, such that the length of BE is equal to the length of DC. Understood? This is given also. Now what we need to prove? We have to prove that AD is equal to AD means join this point with D point, AD, and join this point with E point, AD. Okay, so we have to prove AD is equal to A. How can we prove them? Okay, let us prove. Okay, see, since it is given BE length is equal to DC length, it is given, no problem. So it is given BE, you can write since BE is equal to what? DC, it is given. Okay, now do one thing. Can we write BE is equal to BD plus DE? Can you write it? Can we write BE is equal to BD plus DE? Yes. So BE can be written as BD plus DE is equal. Similarly, DC can be written as DE plus EC. Yes or no? Yes. DE plus EC. Understood? Now we will do what? See, in the left hand side we have a distance D, and in the right hand side we have the same distance D. So we will move this D to the left hand side so that they will be cancelled out. So BD plus this is D. Now whenever this D comes to the left hand side, it will be minus D is equal to EC. Understood? Now D and minus D cancelled out. So what we get? We get BD is equal to EC. Now this conclusion may be used to prove AD is equal to A. Let's see how it is used. So what we have find? We have find that BD is equal to EC. BD, this distance, is equal to EC, this distance. Okay. So now we will prove AD is equal to A. AD is equal to A. For this, you have to first think AD is a side of which triangle? See, we can take this as a triangle. ABD is a triangle. Yes or no? Yes. Similarly, we can take ACE as another triangle. Isn't it? Yes. And if we can prove that this small triangle is congruent to this small triangle, then according to the exam 7.2, we can say that their sides must be equal. They are the corresponding parts of the two congruent triangles. So we have to first prove that this small triangle is congruent to this small triangle. Okay, let's compare them. So after this, you have to write between triangle ABD and triangle ACE. What are the conditions that you get from it? See, here, since AB, this line or this side of the triangle ABD, AB is equal to AC of the triangle AC. Why? Because it is an isosceles triangle, and in an isosceles triangle, this distance AB is equal to AC. So, can we write AB is equal to AC? Because it is given already. It is already given. See, AB is equal to AC. It is given. ABC is an isosceles triangle. Understood? Second thing. Now revise the theorem number 7.2. What does theorem 7.2 tells you? Theorem 7.2 tells you that if in an isosceles triangle, any two sides are equal, then the angle opposite to this side is this angle, and the angle opposite to this side is this angle. Then they must be equal. Okay, in an isosceles triangle, if two sides are equal, then the opposite angle must be equal. So here also, as you know, here AB side is equal to AC side. Yes or no? Yes. So we have AB is equal to AC. Why? Because ABC is an isosceles triangle. Isn't it? Now, if AB is equal to AC, then can we write this angle, which is the opposite angle of AC line? See, if AC is the side, then its opposite angle is this angle, and if AB is a side, its opposite angle is this angle. Then can we write this angle is equal to this angle? Yes, we can write. So angle B is equal to angle C. Why? Due to theorem 7.2. So here is the second condition is the B angle of this triangle ABD is equal to C angle of the triangle SCE. Okay, why? You have to write that. What is the reason? The reason is that theorem 7 and this is given. Now third condition. The third condition is that in this triangle ABD, this side BD is equal to this side EC, because we have symbolically represent them and we have found it. Okay, BD is equal to EC. We have found that this side is equal to this side. So we can write BD is equal to EC. First you have to identify which two triangle I am comparing. I am comparing this triangle with this triangle. Okay. Now what we get? We get that this side, and the included angle. Similarly, this side, and included angle. So these two triangles are congruent under the congruency of SAS. So we can write, hence by SAS congruency, triangle ABD is congruent to the triangle AC. Understood? So now we have proved that this small triangle is congruent to this small triangle. Now remind the axiom number 7.2. According to axiom 7.2, we know if any two triangles are congruent, then their corresponding parts, corresponding sides, corresponding angles must be equal. Now, AD is the corresponding side of which triangle? ABD triangle. Isn't it? AD is the corresponding side of ABD triangle. And AE is the corresponding side of SE triangle. But what we get? We get that this triangle and this triangle are congruent. Since these two are congruent, then we can write that AD is equal to AE. Hence we can write AD is equal to AE by axiom 7.2. Now it is proved, and we need to prove this statement. AD is equal to AE, and we have proved it. Understood? So now move to the first question of the exercise 7.2. The first question gives you that in an isosceles triangle ABC, here also you have to draw an isosceles triangle. As soon as you read the question, you have to start drawing. So ABC is an isosceles triangle in which AB is equal to AC. So this side is equal to this side. This is given. Okay. So first write what is given. It is given AB is equal to AC. Now, if AB is equal to AC, then can we say that this angle is equal to this angle? Can we say? Because these are the opposite angle of the equal sides. We have studied it in theorem 7.2 that if any two sides are equal of an isosceles triangle, then their opposite angles must be equal. So this angle is equal to this angle. Okay. So ultimately what we can write? Ultimately we can write that angle B is equal to angle C by theorem 7.2. Understood? Next thing, what is given? The bisector of B. So we have to draw the angle bisector of angle B. Okay, let's draw. So suppose this is the angle bisector of angle B. Right? So angle bisector means what? Angle bisector divides this angle into two equal halves. It means this is equal to this. Clear? And the angle bisector of another angle C. We have to draw another angle bisector of the angle C. So let's draw. Suppose this is the angle bisector of angle C. Understood? It means this part or this half is equal to this half. This is clear now? Okay. Then both the bisector, the angle bisector of B and the angle bisector of C intersect each other at O. You can see this is the angle bisector of B, this is the angle bisector of C. Now both the bisector meet each other at a point O. This is given. Okay, they will meet each other at a point O. This is given. Right? So here OB is the angle bisector of B. OB is the angle bisector of B, right? And OC is the angle bisector of C. Clear? If OB is the angle bisector of B, then we can write that this angle means OBC is equal to OBA. Implies OBC is equal to OBA. You have to write it. You have to define every concept here so that it is easy to prove. Similarly, if OC is the angle bisector, then this angle is equal to this angle. This angle means OCA and this is OCB. And OCB is equal to OCA. This is clear now? What are the concepts we get? We get AB is equal to C. This is the first concept. We get angle B is equal to angle C. Second concept, and we get this angle is equal to this angle and this angle is equal to this angle. Right? So now join A to O. What we have to do? We have to join A point and O point. Let's join. Clear? Then you have to show that OB is equal to OC. So what to prove? Here you can write, or here you can write, to prove OB is equal to first statement, OB is equal to OC. Then the second statement, AO bisect A. So let us first prove this statement, OB is equal to OC. OB means this, OB is equal to OC. Right? How we can prove? Let's see. Proof. Look at it carefully. It is a little bit lengthy question. Since it is given that AB is equal to AC, so from this data we get B is equal to C by theorem 7.2. So we can write angle B is equal to angle C. We can write it as angle B is equal to angle C. We know it. It is given. Now do what? Multiply half or divide it by 2. By 2. By 2. Okay. See, by 2 means what? By 2 means this angle is divided into 2 equal halves. This angle is divided into 2 equal halves. And this angle is divided into 2 equal halves. Why? Because OB is the angle bisector and OC is another angle bisector. So B by 2 means what? Half of this total angle. Half of this total angle means either you can write this angle or you can write this angle. Understood? So B by 2 means half of the angle B. Half of the angle B means either you can write this angle means OBC. is equal to half of the C angle means you can write OCB. Clear? Clear? Or what can we write? Or you can write half of this angle means this angle OBA, and half of the angle C means this angle means OCA. Understood? So what we get here? We get that OBC is equal to OCB. OBC, that means this angle. Okay, this angle is equal to OCB. OCB, this angle. Right? And OBA. OBA, that means this angle, is equal to OCA. OCA, that means this angle. Okay, understood? Okay, now consider the triangle OBC. Which triangle? In triangle OBC. In triangle OBC, as we have found that this angle is equal to this angle. Okay, now put theorem number 7.3 here. According to the theorem 7.3, if in a triangle any two angles are equal, then the opposite side of this triangle is this side and the opposite side of this triangle is this side. If in a triangle any two angles are equal, right, then the opposite side must be equal. Similarly, here in this triangle, what we have found? We have found this angle is equal to this angle. So, can we write the opposite side of this angle is OB and the opposite side of this angle is OC? So, can we write OB is equal to OC? Yes, we can write. Okay, angle B is equal to angle C. So, we can write OB is equal to OC. Understood? Due to theorem 7 point, this is now clear. Okay. So, we have proved that OB is equal to OC. That means this distance OB is equal to this distance OC. Okay. Now, we need to prove this statement OB is equal to OC and we have proved it. So, this is the proof for the first statement. Clear? Now, moving to the proof of second statement. In the second statement, we have to prove AO bisect A. That means AO is the bisector of angle A. So we have to prove that AO is the angle bisector of the angle A. Angle bisector means what? Angle bisector means we have to prove that this angle is equal to this angle. We have to prove this statement. Let's prove. Okay. So how can we prove it? For this, we have to take or we have to compare these two triangles. Okay, which triangle? We have to compare the triangle ABO. Which triangle? Read my hand. ABO. So between triangle ABO and which triangle? ACO. ACO. This triangle. Triangle AC. Okay. So what are the conditions here? See, in the triangle ABO, in this triangle, OB is a side, yes or no? Yes. Similarly, in the triangle ACO, this triangle, OC is the other side. But what we have proved? We have proved this side is equal to this side here. So can we write it for the first condition? Yes, OB is equal to OC. Why? Already proved. Understood? Second thing, let's see. Since initially we have proved OBA, that means this angle is equal to OCA, this angle. Here we have proved OBA is equal to OCA. See, OBA, this angle is equal to OCA, this angle. We have already proved it. See this. So OBA is equal to OCA. Already proved. Now the third condition is, as it is given that if ABC is a triangle, which it is an isosceles triangle, and here AB is equal to AC, it is given AB is equal to AC. Now if we consider this triangle ABO, this triangle, then AB is a side. Similarly, if we consider SCO triangle, then SC is another side, but it is given that AB is equal to SC. Understood? So let us find which congruency it follows. We have taken this side, so this is for side, this side, this is for side, and this angle. So by SAS, A is the included angle. Hence we can write by SAS congruency, this triangle is congruent to this triangle. Okay? So let's write by SAS congruency, triangle ABO is congruent to the triangle ACO. Now we have proved that this triangle is congruent with this triangle. That means these two triangles are equal or congruent. Now remind the axiom number 7.2. In 7.2 we know if any two triangles are equal or congruent, then their corresponding parts, for example their corresponding sides and corresponding angles, must be equal. Since these two angles or these two triangles are congruent, then we can write that this angle, this is the angle for which triangle? ABO, is equal to, this angle means angle OAB, implies angle OAB can be equal to this angle of the triangle SCO, because these two triangles are congruent, that means their angles must be equal, so is equal to OAC. Do you understand? We get it from this concept. Since these two triangles are congruent, so the angle must be equal. You can write theorem axiom 7.2. What we have found? We have found that this angle is equal to this angle. It means what? These are two equal halves. It means what? It means this line OA bisect the total angle A. Okay, since this angle is equal to this angle, it means this line OA bisect the total angle A. Or you can say AO is the angle bisector of A. Okay, implies AO is the angle bisector of A. Right? So it seems to be a little bit hazy in this board, but you have to take the screenshot and understand accordingly, then you can easily understand two concept or two proof. Okay.